Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VIGNANA VJEC. I welcome you all to the lecture series on payment materials, and the topic of discussion for today will be tests on bitumen. So in the previous lectures, as a part of payment materials, we have discussed the tests on aggregate, so the strength test on aggregate, and also we have covered the shape test on aggregate. Now we are going to discuss the tests on bitumen. So basically, you have to understand what is meant by bitumen. So bitumen is nothing but a hydrocarbon material. So this is an hydrocarbon material which is obtained from the fractional distillation. The term is very important. So this is going to be obtained from fractional distillation of crude oil. Fractional distillation of crude oil. So basically you are going to get the crude oil, and that is supposed to process by subjecting that to fractional distillation, where you are going to get different fractions like naphtha, kerosene, diesel, like that and all. So those are getting at the higher levels, and the last residue, that is nothing but the bottom of the barrel, that is left over, is said to be the bitumen. So that is what we are going to discuss today. I'm not going to detail into the chemistry of the bitumen. So we are looking at the different tests that we are going to conduct on the bitumen. So the first 4 tests mentioned over here: the penetration test, the ductility test, softening point test, and viscosity test. These are regarding the consistency test of the bitumen, as they are going to discuss regarding the characteristics of flow. So that is why this comes under the consistency test. And the last one is nothing but flash and fire point. This is a safety test, unlike the other test what we have mentioned. So those are consistency tests, and this is nothing but safety test. So the first test what we are going to look into is penetration test. The aim of this test is nothing but to find out the penetration value of the given bitumen sample. So the very important core property what you are going to have by the end of this test is nothing but you are going to measure the hardness or the softness of the bitumen. Simply you can find out the grade of the bitumen. So this is nothing but you will get an understanding of grading of the bitumen what you are going to use. So this is, again, I've just mentioned, it is nothing but a consistency parameter. Here we'll just look into this term later. So higher penetration is nothing but softer bitumen, that we'll look into later. So here I'm going to have a penetrometer like this, which is used to conduct the penetration test, and there is a brass mold over here where I'm going to take the required amount of bitumen sample. So I've just got a bitumen sample over here in the this brass mold. So I'm going to get a required amount of bitumen in this. So this is a brass mold basically. So because of heating, it has turned into black in color. So here again, so the amount of load what you are going to apply here is nothing but 100 grams. And the time duration for which you are going to apply the load is nothing but 5 seconds. So you are basically applying 500 grams of the load, 100 grams of the load for a duration of 5 seconds. And you are seeing how much is the depth of the penetration of the needle. So we are going to have a needle over here. Okay. So this is the brass mold which I have got over here. So which is of diameter approximately 50 to 55 mm, and the height is also approximately 50 mm. I'm going to have a needle. So I did not bring the needle of the penetrometer, but this is almost the just like this which we are having over here. So and then there is a needle over here. So I'm going to have a needle which is touching the surface of the bitumen surface in the mold. So I'm touching this bitumen surface, and then you are going to press the needle what you are having. So I'm going to press this needle which is present over here. So this is what I'm having. So I'm going to press this button. Once after you press the button for 5 seconds, as I've just mentioned, the duration for which you conduct the test is 5 seconds. Then there will be some depth of penetration of this needle into this bitumen surface. So that depth of penetration is simply called as penetration value of this bitumen. So this is an initial condition where the tip of the needle is just touching the surface of the bitumen, and after 5 seconds where I have applied the 100 grams of the load, the depth of the penetration of the needle has been gone to this level, and this is what finally the penetration reading what we are having. So the penetration reading can be obtained from the graduated arc which is provided over here. So there is a graduated arc over here. So you can see the readings which is starting from 0, the 400 reading. So here it is 400 reading at the top surface, or that itself can be taken as 0 also. And this is nothing but again 100. So it is divided into 4 quadrants. So this basically being 200, this basically being 300, and this basically being 400. And the depth of penetration what we are having in the needle, what we are having in by the needle is just only to a depth, because the entire mold itself we are having only to a depth of 50 mm. But why the reading has been given up to 400 means we are just exaggerating the readings. Because if I have just given directly the mm values over here, some person may read some reading as 3 mm, and other person may read as the same reading as 4 mm. So because of which you are going to get an error of 1 mm in the reading. of the penetration value. So because of that, in order to avoid this error, we are just exaggerating the readings present over on the graduated arc, and we are increasing. So 3 mm and 4 mm are being increased by 10 times. So this is nothing but 30 and this is nothing but 40. So we are just providing extra readings between 30 and 40. For example, some person may read the reading as 31 and the other person may read as the reading as 32. The only difference is this is 3.1 and this is 3.2. It is only a difference of 0.1 mm. It is only an error of 0.1. But whereas previously, if I just directly give the readings over here in terms of mm, so then the difference of readings between two persons who is looking into that apparatus will be different. So in order to avoid that error, we are just exaggerating the readings, and I'm just increasing the readings by 10 mm. 10 divisions. So that is nothing but here whatever you are going to get. For example, if I'm getting a reading of penetration as 100, so it is nothing but 10 mm. So that is what you have to understand in this test. So it is also represented as 1/10 of the mm. 1/10 of the mm. So the units for this is nothing but 1/10 of the mm. For example, I have got the reading as 100, which means nothing but 100 by 10 is nothing but 10 mm is a reading in the penetration value of this bitumen. Okay, next one, higher penetration is softer bitumen. So if you are having the higher penetration, it means nothing but the needle is penetrating to a larger depth, which means nothing but the bitumen is softer. Once the bitumen is softer, you have to use that in cold conditions, because the conditions are already cold conditions. Then you can use the soft bitumen. But whereas the conditions are harder, warmer conditions, the climate is very high, temperatures are very high. In that conditions, you are going to use the hard grade of bitumen, wherein which the penetration is very less. So that is nothing but the vice versa of this. Less penetration is equal to hard bitumen. So that is what the outcome of this. You have to take into the readings which are very important. So the amount of load that you are going to apply is nothing but 100 grams, and the time duration for which you are conducting the test is nothing but 5 seconds, and the test temperature is nothing but 25 degrees centigrade. And before doing the test, you are required to condition the sample. So just like you take the bitumen sample whatever you are having and heat that somewhere around approximately 70 to 80 degrees centigrade, and then that will become into semi-solid or workable condition, and you transfer the required amount of the bitumen into the penetration mode. And after that, it is conditioned in air for 40 minutes, and then it is also conditioned in water for another half an hour, and then this mold is directly brought below the penetration mode, and the test is conducted just like as I've mentioned. So the reading graduated circle is like this, and the after the testing condition is 0 at time 0 seconds and time 5 seconds. And this is an example which I have got over here. So initially I have taken one reading where I have taken the needle and I have touched the bitumen surface at that time. So once the bitumen's needle is touching the bitumen surface, then there is a mobile this thing rod over here. If I press this, the reading which is obtained as 125 mm. So that is nothing but my initial reading. So once after the needle is touching the surface of the bitumen, so there is a rod which is present over here that I am pressing onto this. Then I am going to get the initial reading as 125. And after that, after the application of 100 grams of load for 5 seconds, again the depth of the penetration has been increased, and then this needle will be going inside. So again, if I move the graduated rod which is present over there inside, so then that will be showing a different reading previously when compared to previous condition. Here it is 125, somewhere around very close to 125, and this is somewhere around 185 mm. So that is what the difference of reading. So 185 is the final reading and 125. So that is nothing but the difference of readings what you have got is nothing but 60. So 60 is the penetration value. 60, just units are nothing but 60, or it is also called as 1/10 of the mm or 0.1 mm. So if you want to convert this into mm, so this will be nothing but 6/10 of mm. So that is nothing but 0.6 mm. Sorry, 1/10 of mm. So that is nothing but 6 mm is the penetration value. So this is how you conduct the test. So here is the observation sheet which is available with me for penetration value. So the dial reading initial and final, just like I have mentioned, this is nothing but 125 and this is nothing but 185. So the difference of the value, penetration value, will be somewhere here in this case it is 60. Similarly, you have to do the you have to take 3 observations for the same sample. One sample you have to take 3 observations like this. So you have to take the readings at 3 different conditions, 1, 2, 3, such that they are at least 10 mm away from the periphery of this mold. At the same time, the distance between 2 points where you are taking the reading should not be less than again 10 mm. So you have to take in the form of a triangle shape in the 3 locations. So then you are going to get the readings at the second instance. sample 1, test 2, and followed by the sample, the same sample and the test 3, you are going to get somewhere around 65, and next again this is also some 60 like that. So somewhere around you have to take the average value something 63. 63 is the penetration value, and if you want to express that as in mm, so this will be 6.3 mm. So generally you express that in penetration value directly, which is nothing but 63. So like that, if you have other sample, you can do the same test. You can carry the test in the same procedure. So here are the penetration grade. In Indian conditions, we are having the different grades what have been represented over here according to the availability. So this A stands for Assam Petroleum. The source of origin for the bitumen is nothing but Assam. So in this case, it is A25, where in which the depth of the penetration and the penetration value is 20 to 30. It means nothing but the average value is 25. And similarly, from Assam region, so you are having a 35 grade. If it is from some other region, so anywhere other than Assam, it is represented as yes. So again, the reading is 35, which means nothing but it will be the penetration value will be 30 to 40, and the grade of the bitumen is nothing but 35. Similarly, you have the final grade as 175 to 225, where which is nothing but A200. So this is the 200. Or generally sometimes there will be another representation like 30 by 40 or 60 by 70 like this. So whereas the same thing 60 to 70 can be represented as 60 by 70 or 40 by 50. So we'll be denoting the grade of the bitumen as like this 40 by 50. It means nothing but the value will be somewhere around 40 to 50 mm, or we'll be representing it as simply A45 or S45. Next, the other test what we are going to look into on the bitumen is nothing but ductility test. So determine the ductility value of the given bitumen sample. So in the previous condition, we have find out the core property of the bitumen, which is nothing but the softness or the hardness of the bitumen. Lower the penetration value, harder is the bitumen, and harder is the bitumen, we are going to use that in the higher warmer regions or high temperature conditions. So in the vice versa, it is a different condition. Higher penetration value in the colder regions, and that is in that condition you are going to have. So the next test is nothing but the ductility value. So to determine the ductility value of the given bitumen sample, it means nothing but it is used to find out the property of the bitumen in which the bitumen can be expanded like a thin like wire. So that is what you can observe in the bitumen test. Again, the test temperature, the processing of this bitumen, again I have got the briquette mold over here. So I've got the briquette mold over here. So you can see the briquette mold over here. So this is the same what I've got in my hand. So this is nothing but one side of this mold and the other side of this briquette mold. There are again some two interior parts which are present over here. You have to fill the bitumen in this portion, whatever is being provided over here. So you can see this, you have to fill the bitumen into this portion, and after that again the bitumen sample is allowed to condition in air for again half an hour, followed by in water for 45 minutes. Then you have to remove these portions. So before that, I just forgot to mention here, you have to apply the glycerin portion on the top of this mold on this surface, because you have to remove this sample out of this. So in that condition, it should not stick to the surface of this plate. So that is why you are going to apply the glycerin. After that, so after the completion of the conditioning, you have to remove this both the end conditions, and also you have to remove this. You shouldn't remove this both the plates. So only you are supposed to pull out of this. Once you pull out of this like this, so you are going to get the bitumen briquette like this. So once you get out of this, so you have to remove the inner these things. So you have to remove both of this inner, and you are going to get the final product is a bitumen shape like this. You are going to get. So only this briquette along with this end plates you are going to get it, end arms. So that is only you are going to get it. So that entire assembly has to be placed into this chamber. So this is the basically the drum or the machine what you are going to have. You have to place this like this. So on one side, so one side of this is nothing but fixed, the other side it will be keep on moving. So once I keep this entire assembly, there won't be any plate over here. There won't be any plate. So I'm having a bitumen sample here. So this will be connected to the fixed arm, and this will be connected to the mobile arm of the ductility machine. So and this will be pulling. So the rate of pulling will be somewhere around 5 centimeters per minute, and this will be the other side will be keep on pulling. So thereby which the bitumen will be elongated. So thereby it will be subjected to some amount of elongation, thereby which you are going to get the ductility value of this bitumen sample. So here the rate of movement will be 5 centimeter per minute. 5 centimeter per minute. So this is the drum what you are going to have, and this is how this fixed arm, and you'll be having on the side it will be a mobile arm like this. So you'll be having a mobile arm, and that will be connected to the shaft. So this will be moving like this, and there is a graduated scale which is present over here from 0 to 100. So once you are about to start the test, So just after keeping the briquette inside, so you have to make sure that the scale on this is reading 0. And after that, while within movement, you are going to get reading a different value, and the moment at which the bitumen sample which has been elongated will be cut in the middle portion, and that then you have to take the reading on the scale that will be represented as the ductility value of the given bitumen sample. And it is going to measure the elongation before breaking. It is going to indicate the adhesion and the tensile behavior, and is also going to give the elastic property. We can understand what is the how the bitumen is going to coat the aggregates that is coming in contact during the preparation of the mixed design. So this is what you're going to have starting point, and after that end point just before breaking. So this is how, and this is the value will be represented on the surface of the scale. So again the same thing, we are having observation sheet over here. So you can place at a time 3. There is a provision of providing 1, 2 and 3 briquette molds at a time. You can take the average value. So for example, if I'm getting one as 80, other one is 82 and the other one is 84, then you can directly represent the mean value as 82 centimeters. So that is what the ductility value. So previously it is nothing but in penetration value is just in number. So 60 or 70, 60 by 70, but whereas here the ductility value will be in centimeters. The average value you have to represent, and that is the ductility value of the given bitumen sample. The other third test what we are going to look into is nothing but softening point test. So the name itself is indicating that. So you have to find out the temperature. It's basically a temperature. Just like in the previous case, the ductility is nothing but centimeter. So this is a temperature. Okay, then what is the temperature? It is the temperature at which the bitumen is becoming soft. So we have seen that when we want to work with the bitumen, we have to heat that bitumen to a considerable temperature such that it becomes workable and make us to allow for preparation of the samples. So that is what the temperature at which we are looking into. Softening point. So the apparatus what I'm having over here is nothing but so a glass beaker which is present over here, and a sample holder. This is a sample holder which I'm having over here, and the apparatus name is said to be ring and ball. So we are going to have a rings over here. So this is basically one ring. So this is the original ring what we are having. So again you have to take one plate. You have to take one plate and you have to pour the bitumen. So previously just like in the briquette mold of the ductility machine. So you have to clean this plate along with glycerin, and you have to put the plate over here and you apply the bitumen. So you pour the bitumen up to this level. So again you subject that to conditioning for half an hour in air followed by in water, and you bring this sample like this. So this is our original ring, and there you are having another ring which is nothing but a supporting ring. So here in this condition you'll be having groove on one side of this supporting ring. Okay, you'll be having a groove like this, and you'll be having groove on one side of this original ring, so brass ring. So this groove will be upside, and this groove also will be upside. So you have to just insert the top ring onto the inside the bottom ring. So just like this, you're going to 3 steps: 1 step, 2 step, 3 steps. You can see from this you're going to get 3 steps out of this: 1 step, 2 step, 3 step. So this is how you have to fix your brass ring. Okay, and after that the entire assembly what you're having is to be reverse like this. So you have to make it reverse, and this last step or last groove is going to fit into this sample holder. So this is how you have to make the arrangement for doing the softening point test. The similar way I have done for the other thing. So here the minimum thing is nothing but you have to do the softening point test for minimum 2 balls, and then you are going to have 2 balls. So that balls should be kept on the top of this bitumen sample. So I did not get the balls over here. Once your sample is there inside, so if you keep the ball in place, so that will be at that same condition. And after this entire sample holder along with the balls is kept inside this glass beaker. So just like I have mentioned over here, so this is a glass beaker, and you have to fill this glass beaker up to somewhere around up to this level, such that the there won't be more than 1 centimeter from the brim of this glass beaker, and then you have to subject this entire glass beaker to heating. So you have to again heat at the rate of 5 degrees per minute. So per minute you have to increase the temperature. So 5 degree centigrade per minute, and you have to keep on heating such that the initial ball will be in this condition. So balls at the static condition. After that, once water gets boiled, so then there will be the balls will be coming to the bottom of this holder, sample holder. The gap between these two is nothing but 1 inch, which is nothing but some 2.54 centimeters. So and then one ball will be falling and the other ball also will be falling at some point of temperature. So if both of the balls fall at the same temperature, then you have to take the reading as the softening point. If two balls are falling at two different temperatures, then you have to take the reading. For example, it is 50 and the other one is 52 degrees centigrade. So this is one ball has fallen at 50 and the other ball has fallen as 52 degrees centigrade. So then the average value will be represented as the softening point of the bitumen. So the temperature at which the bitumen softens is said to be the softening point. Higher value is the better high temperature performance. So just like higher value will be the better high temperature performance. Your service temperatures are very high. That means nothing but warmer regions and all. You expect the bitumen to have a higher value of softening point. It means nothing but the bitumen is again a hard grade bitumen, which is nothing but a lesser value of penetration, hard grade bitumen, which means nothing but you are going to have a depth of penetration as only 30 to 40 or 20 by 30 grade of bitumen. The same way you are going to have higher value. So higher the value is suitable for better high temperature performance. So this again the observation sheet which I have got along with me for calculation of the softening point. So this is the ball one, just like I have mentioned. So the one ball has fallen to the bottom, so at 50 degrees centigrade, and the other ball has fallen at 52 degrees centigrade. Then you have to take the average value. 51 degrees centigrade is the softening point of the given bitumen sample. So this is all about the softening point of the bitumen. The other one is very important, absolute viscosity. So far we have discussed three of the consistency tests, namely penetration value, softening point and the ductility. And the other test which is very important is absolute viscosity. Why I mentioned this as very important is nothing but this is one test of the bitumen where you are directly relating to the performance of the bitumen or directly the flow characteristics of the bitumen or the original bitumen properties being reflected in the viscosity. But whereas other test, particularly penetration grade of bitumen, is an empirical test, but it is also used to classify the grade of the bitumen. The other grade of bitumen what we have is nothing but viscosity grading of bitumen. So that is can be obtained from the by calculating the viscosity from doing this viscosity test. So again, to determine the absolute viscosity of the bitumen test, we are going to have two viscosities in this condition. One is nothing but the absolute viscosity, which is going to conduct at 60 degrees centigrade. So this is what the chamber which I am having. So this is the machine which I have here to conduct the viscosity test. So there is this chamber and there is the liquid inside, which is either silica gel or water. So if you want to increase the temperature beyond 100 degrees centigrade, so you cannot use water. So generally we will be using silica gel as a liquid for measuring the viscosity of bitumens. And it is used to find out the measures flow resistance and is also important for mixing and compaction temperatures. So I'm not going to deep into the mixing and compaction temperatures as beyond the scope of the UG program. And here there is one viscometer which is present over here. So this is also called as Cannon Manning vacuum viscometer. I have got the viscometer along with me. So this is one viscometer. So the name itself is mentioned over here. So you can see that this is Cannon Manning vacuum viscometer. And again, the number of the serial number of the bulb is also given over here. It is nothing but 13. So it is basically a vacuum viscometer, and the name of the viscometer is nothing but Cannon Manning vacuum viscometer. So this is viscometer what you are having. So this is the larger side of the bulb for the viscometer, where I have to take the 20 ml of the bitumen. Again, you have to hit the bitumen to softening point temperature, and you have to condition that bitumen, and you have to pour 20 ml of the bitumen such that the bitumen inside this is coming up to this level. So this is what your marked level, such that you have to pour the bitumen up to this level. And this entire this setup, the viscometer has to be kept in oven at 135 degrees centigrade. To remove any air gases that is present, any air gaps that are present inside this for approximately some 10 or 15 minutes. And then you have to transfer this entire viscometer into this chamber, into this viscosity chamber, viscosity measuring chamber. And then you have to condition again for half an hour. So that is allowed to stay at this temperature for half an hour. So that is very important. First one is nothing but you have to take the 20 ml of the bitumen into the larger side of this viscometer up to this reading, which is very important. And after that, this is kept in oven at 135 degrees centigrade for 10 minutes for in order to remove the air voids. And then this entire viscometer is being shifted to the viscosity measuring chamber, where we are going to allow it for conditioning for 30 minutes. And after that, as at this condition at 60 degrees centigrade, basically bitumen being hard, it will not be able to flow. So this bitumen has to flow on the reverse side. So I have poured the bitumen on this side, but we are measuring the flow against the gravity in this direction. So that is what you have to understand. This cannot happen at 60 degrees centigrade on the bitumen. So it cannot happen on its own. So because of which you are going to connect some vacuum pressure over here. So you're going to connect a vacuum. So I've provided the vacuum pump over here, and you have to measure, you have to supply 300 mm of Hg. So that is what the pressure you are required to supply. So after conditioning for half an hour, you have to connect the vacuum pump over here, and then you have to see the reading. So here you can see the bulbs. This is the bulb B and this is the bulb C. These two bulbs are very important. So once again I repeat this. This is the central bulb, which is nothing but the bulb C. So here I am having the bulb C, bulb B, and this is the bulb C. I'm writing over here. So this is nothing but B, and this is nothing but B. This is nothing but C. So I'm having a marking over here. So this is a bulb B and this is the bulb C. Up to this. So you're having some extra bulb over here, so that is not required here. That is also provided over here, but that is not of our interest. So this is bulb B and this is bulb C. Ultimately what you are going to measure is simply in this test, because we are already having the calibration factors, we are just seeing that by the time once you apply the pressure, vacuum pressure, the bitumen will be start flowing inside from the bottom of this viscometer. So it will start in this condition, and it will reach up to this point, so bottom of the bulb B. So once it has come to the bottom of the bulb B, you have to switch on your stopwatch. So you have to switch on your stopwatch, and you see what is the time taken by the bitumen to travel through the entire bulb B. So you have to note the time T1 as the bulb B. Okay, and after that you don't stop the stopwatch and allow it to continue till the bitumen is reaching to the top of the bulb C. I repeat again, the bitumen has started flowing from this point. You have started your stopwatch and it is in on, and the bitumen has flown up to this condition. You have noted the time. You don't stop the stopwatch and allow it to continue. So, but you have basically noted the reading after the completion of the bulb B. And again, you take the cumulative reading of the time till the completion of the bulb C. Okay, so that is nothing but the cumulative time. This is nothing but T2. So the time taken by the bitumen to travel from the bottom of the bulb B to the top of the bulb C. And basically, if you want to get the time of the entire time taken by the bitumen to travel only the bulb C is nothing but T2 minus T1. So that is how you are going to get the value of the time taken by the bitumen to travel through the portion of bulb C. Once after you get this times, so then it becomes very easy to find out the viscosity of the bitumen. So here I'm having the calibration chart also over here. So this is the range again, bulb number 13 over here. Okay, and this is the calibration date, and the recommended due date is available over here. So I'm very much interested over here, the bulb B and bulb C, their average constants are very important. So the bulb B is having a calibration value of 61.529. I write over here. So the bulb B flow time, this is the time in seconds for flow time bulb B, and the calibration factor is 61.529, and the calibration factor for bulb C is nothing but 20.391. You also have to understand there is a difference between calibration constant for bulb B and bulb C. You know that the bulb B is at the bottom condition and bulb C is the top condition. So this is the beginning of the test. So you are having so much of resistance. So because of which you are going to have a calibration constant as higher when compared to that of bulb C. And you also have to make a note of the value. So this is very important. So if you look at the calibration constant units, this is nothing but poise per second. Very important. The units are nothing but poise per second. So if I get, for example, if I get 60 seconds multiplied by some 61, so then this is 60 seconds multiplied by this is poise per second. Second gets cancelled. So you are going to get the value of the viscosity directly in poise. So this is a calibration constant which is given, designed like that based on the taking the reference fluid, and they have calibrated like this. We are not going to the deep discussion of how you are going to get the calibration constants. Okay, so this observation sheet what I'm having over here. So I've got some readings how to calculate the value of the viscosity, absolute viscosity. So the time taken for the bulb B is nothing but it is 55 seconds, and the entire time is nothing but 247 seconds. So the entire time is 247 seconds. So but I want to get the value of the bitumen, value of the time taken by the bitumen to traverse through the bulb C. So that will be 192 seconds. That is nothing but 247 minus 55. We are going to get 192, and the calibration factors just I have mentioned, it is nothing but 61.529, and this will be 20.391. So viscosity is nothing but just I have mentioned, it is nothing but the product of calibration factor into time. So 55 into 61.529, and this will be 192 multiplied by 20.391. So that is what you are going to get. But here you have to take for the final average value, for the final absolute viscosity, you have to take the average value of both bulb B and C. You have to take the both average value of bulb B and C. So this is the average value. I've got the value to be 3648. Again, just I have mentioned the units will be poise, because the calibration constant units are nothing but poise per second, and the time is multiplied with second. So second gets cancelled, and again this value will be going to be higher and this value is going to be lower, and you have to take the average value. I've got it to be 3648 is a poise of the absolute viscosity. Very easy test. So only the test temperature is nothing but you have to maintain the temperature of 60 degrees centigrade over here. You allow it to condition for half an hour, and then you have to supply a vacuum pressure of 300 mm of Hg, and then you have to take the time taken by the bitumen to travel through the bulb B as well as bulb C, and then you have to subtract the entire from the entire time. You subtract the time taken by the bulb B, you are going to get the time taken by the bulb C alone. So then you multiply, you are going to get the value of the absolute viscosity. And the other test continued to this is nothing but kinematic viscosity, to determine the kinematic viscosity of the bitumen sample, similar to that of that absolute viscosity, but the only variation is nothing but the test temperature is nothing but 135 degrees centigrade. You are going to keep this entire again viscometer into the same chamber, but it is maintained at 135 degrees centigrade. The only difference is previously we have supplied a vacuum pressure of 300 mm of Hg. In this condition we are not going to provide any vacuum. So I have also got the another viscometer, which is nothing but this is the viscometer number 6, which is used to find out the kinematic viscosity. So again you can see the name of this. So it is nothing but YouTube modified viscometer. So this is the bulb what I'm having. Previously I'm having like this. So in this condition you have to pour the bitumen on the left side. So that is nothing but your 20 ml of the bitumen will be on the higher side when compared to the previous condition where it is at the lower condition. And now you have to take this bitumen and allow the bitumen to flow up to this level, such that it will be coming over here and up to this level. So there is a bottom marking over here. So this is a bottom marking. So you allow the bitumen to come up to this level while conditioning. Okay, just like the previous condition, you take the bitumen along with this viscometer, keep in the oven for 10 minutes to remove the air voids, and then bring this viscometer, keep into the chamber measuring viscosity, and then allow it for half an hour till before that it reaches it should reach to the value of this mark. Once after this mark is reached, you allow this again conditioning for half an hour. So before that you have to close this entire this portion with the cork. Why? Because at this 135 degrees centigrade, the bitumen it can flow in the opposite direction against the gravity. So for that reason, you have to stop purposefully your flow of the bitumen. So you have to provide a cork at this condition and allow it to for half an hour conditioning. And after that, you start noting the time taken by the bitumen. So you remove the cork, then the bitumen will be flowing. So it will be flowing from this bottom of this bulb to the top of the same bulb. Okay, you are having only one bulb, so that is nothing but the bottom of this marking is this, and the top of the marking is nothing but this thing. Okay, you remove just the cork on the top of the viscometer, and the bitumen will be flowing against the gravity without the application of the vacuum pressure. But the test temperature is nothing but 135 degrees centigrade. Previously, before which you have to condition the sample at half an hour at 135 degrees centigrade. So the name of the viscometer is nothing but YouTube modified viscometer. And you are going to have a calibration constant differently for this. Okay, I'm repeating this. We are going to have only one bulb. Okay, again the time taken by bitumen to flow through that bulb A to B, or one bulb only, whatever it is. Okay, so this is nothing but I've just represent only bulb A. Okay, the calibration constant for this again I have mentioned over here. It is nothing but 1.027, and again units are very important. That is nothing but CST, that is nothing but centistrokes per second. And you have to make the note of the time. It is nothing but in this test what I have conducted, the time taken by the bitumen to travel through the bulb is nothing but 420 seconds. So therefore your viscosity is nothing but 420 seconds multiplied by 1.027 CST, centistrokes per second. So this second gets cancelled. We are going to get approximately 431.34 centistrokes. Here previously I got the absolute viscosity in poise, and here the kinematic viscosity I got in centistrokes. So that is the difference between absolute viscosity and kinematic viscosity. The units are different, the test temperatures are different, the pressure conditions are different. So you have to remember that. Again, I'm not going to deep in how you are going to get the units of calibration constant as CST per second or poise per second. That is a different story. So at the completion of these conditions, we have to look into different values. So after completion of the viscosity test, So here we have to take the look after the IS 73, which is very important. The I mean code for paving grade of bitumen. So requirements of paving bitumen. So the penetration value when you conduct the test at 25 degrees centigrade will be 1/10 of the mm, which is nothing but the 0.1 mm. Minimum, it should be minimum. So this is the viscosity grading system. So for VG10 grade of bitumen, I'll first explain how is this grading classified. So if you look into this viscosity of this absolute viscosity of the VG10 bitumen is 800 to 1200. How do you get that? Is nothing but 1000. You have to take the center value 1000 plus or minus 2 into 100. So that is how you are going to get it. 1000 plus 200 is nothing but 1200 on the higher side, and 1000 minus 200 is nothing but it is 800. So similarly you are going to get the value. This is for VG10. Okay, and this is next followed by VG20. It is nothing but 1000 plus or minus 2 into, you have to take 200. So then you are going to get 1400, sorry 2400. So this will be 2000. This will be 2000, and this will be 2000 minus 400, it will be 1600. Similarly for VG30, I'm writing over here VG30 is equal to 3000 plus or minus 2 into 300. Okay, so that is how you can work out for VG40 also. It is nothing but 4000 plus or minus 2 into 400. So once you are going to get the value of 3200 to 4800. So then how is it related to the viscosity is related to grading of the bitumen is nothing but, here you take the average value. It is nothing but the grade of the bitumen is obtained as 1/100th of average value of the viscosity. Here the viscosity which I am having, absolute viscosity is 800 to 1200. The average value is nothing but 1000. The average value, which means nothing but 800 plus 1200 by 2, which is nothing but 2000 by 2, which is nothing but 1000. So again 1000 by 100 is nothing but 10. So then you are going to add suffix previously, which is nothing but Vg. So that is how you are going to get the value of Vg10. When you are having a viscosity in the range of 800 to 1200, it is said to be the Vg10. Similarly, you take the average value of 1600, 2400, it will be 2000. Average will be 2000. So therefore divide by 100, 1/100th of the average viscosity. Here the average will be 2000 divided by 100. It will be nothing but VG20 and VG30. Similarly followed by VG40. So these are the different requirements what you have to look into. These are the conditions that need to be fulfilled when you are testing the viscosity grade of bitumen. If you have taken VG10, basically this is nothing but less viscous bitumen. It is soft grade bitumen. Okay, and the penetration value, once the soft grade bitumen should have higher value of penetration, because the needle has to penetrate to a larger depth. So therefore the minimum value here, it is very important. You have to check whether it is minimum, whether it is upper bound or lower bound. It is lower bound, it should be 80 mm minimum. Sorry, 80 minimum. Next one is for VG20 it is 60, for VG30 it is 45, and VG40 it is 35. Penetration values. Similarly, absolute viscosity I have just mentioned. So you have to get a value of 800 to 1200 for VG10. So like this, and just previously I have conducted the viscosity of the sample which I have got with me. So which bitumen has come to be, the viscosity is nothing but 3648. So this is coming into the range of 3200 to 4800. So then this bitumen what I have got, it can be classified as VG40 grade of bitumen. So here you can see there is a overlapping. It will be 2400 to 3600, and this has come below that upper bound of the VG30. So there is a overlapping in terms of the absolute viscosity. You have to make a note of that, but that can be rectified through the kinematic viscosity. So kinematic viscosity is nothing but minimum 250, and this is nothing but 300. Minimum this is 350, and this is nothing but 400. For example, but somehow a little bit calculation variation, instead of getting this as 3648, I've got it as 3500. Then it can be classified either VG30, or it also can be classified as VG40. Then you have to check with kinematic viscosity. In the previous condition I have got it to be 431 centistrokes per second. Sorry, centistrokes. So in this condition, as the kinematic viscosity is more than 400, so this can be definitely said as VG40 grade of bitumen. Similarly, you check the other parameters. I'll come to this flash and fire point in a while, and these are the parameters which we have covered. And ductility at 25 degrees centigrade. So this is again test residue from rolling thin film oven. We did not discuss that, so we'll leave it aside. And the flash and fire point, this is the last test. Unlike the other consistency test, is a safety test, very important, as many people will be working with the bitumen and the site conditions and all. They have to be familiar with the temperature at which the bitumen will have the flash and fire catching ability. So we have to caution them by giving these values of flash and fire point. So to determine the flash and fire point of the given bitumen sample, the definitions are very important. Flash point and fire point. The flash point of a material or the bitumen is the lowest temperature Very, very important. Somebody will miss this term. They will mention it as only temperature. But you have to give that is what happening at lowest temperature. Because if this bitumen has the ability to catch 200 degrees centigrade as flash, then it also can catch at 220 degrees centigrade. And it also can catch at 250 degrees centigrade. But we cannot give any higher value. We have to give the lowest value that it is going to happen. Okay, then only the other conditions will be anyhow said if you tell it as 200 degrees centigrade. That is already covered. So that is why the flash point of the material is nothing but the lowest temperature at which the application of the test flame. You have to get the small amount of flame into the test conditions over here. You have to get to very close to the bitumen sample which is heating. At which the applications of the test flame causes the vapor from the material, whatever the vapors which are coming from the bitumen is going to catch the fire momentarily in the form of a flash under the specified conditions of the test. So that is very, very easy definition. It is the lowest temperature at which the vapors of the bitumen from the bitumen sample is going to catch the fire momentarily for a small fraction of time when you get the flame very close to the bitumen sample. So that is what the flash point. And there will be another test temperature, or another temperature at which the bitumen, instead of catching instead of catching the flash for a momentary second, it will just catches the fire and it will just start burning for a few seconds. So that is what the fire point. The fire point is the lowest temperature again at which the application of the test flame causes the material to ignite. And burn at least for 5 seconds under the specified conditions of the test. So this is all about flash point and fire point. This is a safety test. Again, fire point is also the lowest temperature at which the bitumen is going to catch the vapors of the bitumen is going to catch the fire for a few seconds, like 5 to 10, and that is the temperature. So this is all about flash and fire point. So I end the session over here. I sincerely acknowledge the use of publicly available resources that supported and enhanced the visual clarity of this presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.